Okay, we're gonna kind of go back over this example 2 that we looked at yesterday. So the piecewise defined functions are the ones that aren't one singular straight line. It could be made up of 2 or more lines or line segments. Okay, so each line of this function has to be defined in its own way. And we put them all together in one group. So we had the f of x equals, and then the left side of the bracket or the brace, and then all the different rules for each piece of the function. Okay, so remember, like they looked at each part of the function is one line, but you only graph a certain part of it. So for the orangish reddish line, you're just worried about when x is less than or equal to 2. So they just drew the line, but they stopped when x equal 2. And then this line, they started where x was 2 and did everything greater than that. Okay. So you can either like graph the lines themselves and erase everything else, like if you were doing this on paper, or if you're doing it on the computer, like what's probably going to be the easiest here. Oh, no, hold on. That's weird. This is not what we did yesterday. This is the one we were going to do yesterday. And we skipped. Okay, I skipped one yesterday. When you do it on the computer, what would probably be the easiest thing is to make a table and find a couple points on the line and then draw it out. Okay, we'll get to drawing our own here in a second. So we have this graph that we graphed from example 1, and you can see the red line and the blue line. Where is the function increasing? Where does it seem to be getting bigger? Where does the line seem to be increasing? Austin? Which part of the graph?
At the point where it makes it like the middle.
The vertex?
Yeah.
So it's only increasing right here, you say? That's the only spot that is increasing? No? Okay, where, hold on, while you're talking, where else might it be increasing? Not just at that one spot.
At the spot.
Which spot? Where does it look like your line is increasing, Olivia? The positive slope line. Okay, don't worry that this arrow is pointing downward. If you're going from left to right, this looks like it's going up. It's increasing. Your y values are getting bigger. Okay. What about decreasing? Where does it look like it's decreasing? The right side, the blue part. Okay. So yeah, the domain, which is those numbers you put in, it's decreasing here, increasing here, but the range or the like the output of the graph increases here, decreases there. Okay. So you wouldn't necessarily draw a line. We would say it's increasing when it's this line, and this line was our first one, and that's when x is less than 2, or less than or greater to 2. And then it's decreasing once x is greater than 2. Once it hits 2, it changes and starts going back down. Okay, and here, it's either increasing or decreasing because there's only 2 lines. But there are times where you have multiple, like more than 2. So you might have a couple that are increasing or a couple that are decreasing. Okay, okay, let's try graphing one ourselves. And I think the easiest is going to be to just find a couple points on each line and then plot those. And then I'll make the line for it. Okay, so if we're using this first rule, x minus 2 when x is less than or equal to 1. And you only need 2 points. I'm going to use 1 as one of those x's, because then I know exactly where my endpoint goes. And then I need another number that's less than 1. Okay. -2. Okay, if I plug a 1 in here, what is 1 minus 2? Awesome. -1. If I plug in a -2, what's -2 minus 2? Nope. -4. Okay. Then it might work. Okay. Okay. Then I'm going to graph this line. My first point is 1, -1. We're at 1, -1. And then my second point is -2, -4. -2, -4 is pretty close to that. Okay, we have 1 line. Okay, does this part of the graph include 1 or does it not include 1? It includes 1. So it's just like when you're graphing an inequality, or we have that open circle, closed circle thing. This one's going to be a closed circle. Okay. So far, the graphs that we've had are like overlapping at the same point, but we'll get ones where they might look like this. They're 2 totally different unconnected lines. So it's important that 1 is including your stopping point and then 1's not. It'll make more sense when we get to something like that. Okay, and then we're going to use this other rule to graph our other line. Okay. We'll use 1 again just because that's the endpoint. I need a number that's greater than 2. Okay, if I plug 1 in here, what's 1 times -2? -2 plus 3, +1. If we plug in 2, 2 times -2, -4 plus 3, -1. Okay, and then I can plot these points. Okay, so my first one is 1, 1. Right there. Okay, and then my second point is 2, -1. It should be like that. Okay, see how these lines are not actually like touching in any way? That happens. Okay, the absolute value function, yeah, they come at the same point, but this one doesn't. So if I plug in 1, am I actually going to get both of these values? Technically, no. Because does this one include the number 1?
No.
No, it's not equal to 1. It's greater than 1, not equal to 1. So we have to make the endpoint an open endpoint. So you're like, you follow this rule until you hit 1, then everything right up to 1, not exactly 1, you're going to jump on this line. Okay, so one of your endpoints always has to be closed because it includes that x value. one of your endpoints has to be open because it does not include your endpoint. You can't plug it into both equations and get two separate values. Okay. Gotta be, if you plug in exactly one, it's either this one or that. Can't be both. Otherwise, it's not a function. So for each value, only has one output. Okay. Making a little bit of sense? Not at all. Maybe I'll get better. So. Okay. And like, so there's only like 6 or so problems on the homework. There's not a whole lot. This is something pretty advanced. Okay, so. It's okay. This is something totally new. So it's okay if things are a little fuzzy right now. Let's just learn important. Okay, so now we're gonna like analyze the graph. Okay, you see we have a graph here. This is a very good example of a piecewise function. The one we drew yesterday at the beginning of class looks like a straight line. This is not a straight line. You can see it increases a little bit, increases a little more, and then increases a lot. You can tell that each, besides a different color, you can tell each section is showing something a little bit different. Okay?
Cheyenne's mother is reviewing the monthly water bills from the summer. Each monthly bill includes a graph like the one shown, which reflects the different rates charged for water based on usage. Several relatives visited Cheyenne's family in July, and their water bill more than doubled. Assuming that the water consumption did not double that month, what is a possible explanation for the increase?
Okay, so this is showing the water bill. It shows how many 1,000 gallons they used. And then how much like they had to pay for that. Okay. So at the beginning, they weren't using too much. This is still just for 1 month, but they weren't using too much. Then things kind of increased a little bit. So there's this big jump, like they went, and then once they hit so many gallons of water, it jumps up to like another price range. And then once they hit another so many gallons, it jumps up to another price range. And then it's going to continue up there. Okay. So if we're looking right here, right there is where it jumps up to the next price range. How many 1,000 gallons do you have to use before it jumps up to that next price range? 5,000 gallons. Yeah, it's right at the 5. Okay, so everything up to 5,000 gallons exactly, you're gonna like be along this line. Okay, you're not gonna end up paying too much. Just a nice steady increase. Once you go over that, it jumps up and you're gonna be paying more money. And the amount of money that you pay is a little bit more for the extra water. So like it's gonna increase more. So if you use less than 5,000 gallons, it's gonna be pretty like low bill. Once you jump up, they're gonna charge you more per gallon. Why? I don't know. Usually you get a discount when you use more or something. But now that you're using more water, they're gonna charge you. Okay. And then here is where it jumps up to that third tier. How many 1,000 gallons do you have to use before you jump up to that third tier, Austin?
No.
10,000 gallons. And once you hit 10,000 gallons, everything after that is going to be charged on this tier 3, and it charges you way more for each gallon of water that you use. Okay. And so this is like the graph that they would use. Okay. And they said that Cheyenne's water bill more than doubled not double. What's another possible explanation for these increases? Okay. If we had a regular function, it would increase at the same rate over time. Because we have a piecewise function, it increases at different rates. Okay, so yeah, we follow this little slider along here. If we use 0 gallons, you don't pay anything. But as I jump along, the more gallons I use, I follow that red line, and then it moves to the blue line, and then it moves to the green line. And I can use a bunch more. Okay. The large increase in the bill probably resulted from extra usage plus jumping from one tier or one method of charging to another one. So like here, if we use 5,000 gallons, it looks like it's going to be about $5. Okay. If I use 5,001 gallons, this is 5,000 right here. If I use anything more than 5,000, one more gallon, now my bill is $10. And it doubles just like that. 1 gallon costs $5 extra. Okay, so they may not have had to double their usage to have to pay twice as much. They tend to be like the more you use, you might get charged a little extra. So having to give you more. Yeah, so the large increase in the bill probably resulted from usage increasing across one boundary from either tier 1 to tier 2 or tier 2 to tier 3. At the tier 1, tier 2 boundary, 5,000 gallons of usage results in a bill of $5, while using just a slightly more water results in a bill of $10. Kind of like a service charge. Oh, you're going to use 5,001 gallons of our water, you're going to have to pay $5 more. Oh, you think you can use more than 10,000 gallons of water? We're going to charge you $10 more. Just because you went over that certain amount. And you can see that just by looking at the graph. You don't need to know exactly how much water they used to know how much they spent. They're not really asking you that. But you can see that there's like an increase in price. Then another. Okay, so we're looking at the same thing. Why might a utility company charge more for more water being used? Like, think about real world, okay? Think about if you were a company with water or whatever you're providing for a household. Why do you think they charge more? You know, like if you go to the store and you buy a small box of cereal, you pay so much per ounce. But when you buy a bigger one, usually it's less per ounce. This is opposite. Why are they charging you more money if you use more water? Awesome.
Because you use not well for it. That means they don't have to use water.
I mean, yeah, you are using more water. What about that water makes it more expensive? 5,001 gallons means you pay way more money. Like, why does that one extra gallon cost up so much money? It's hard because you're kids and you don't understand home ownership yet. What runs under the streets? Sewers and water pipes that brings water to your house. Okay, if you're using more water, what's happening to the water in the pipes?
Shower.
Oh, well, they're using more of it. Like they're having to push more water through the pipes to get it to your house, right? Okay, the more that something gets used, what's likely to happen to it? Break. So the more water you use, the more it actually wears down the stuff underground. The more it wears the pipes in your house, the more likely things are to break. So they're kind of using that money as a way to save up for something bad. So again, the more water you use, the more water probably ends up going down to the sewers, which again, you know, things can go wrong with that and can cause problems. So it's kind of helps pay for all of the sewer usage. That has to go to this. Here in York, it goes to this special place outside of town now, and then like gets treated and stuff. It's helping to pay for all that extra water having to go up. Yeah, I don't know how much it costs when a water main breaks, but the big pipes under the roads that pull the water. To fix one of those, you've got to dig through the cement, and pull, dig the dirt out, cut the pipe, get a new piece of pipe, put it down, and weld it all together. They let it sit for a couple days to make sure it doesn't break again, because that's happened, where it's broken multiple times at the same time. And then once it's good, then they take more dirt, pack it on top of concrete, and put it over the top. Okay? Kind of, yeah, they replace like a giant water main. So it takes a lot of time. When these break, just randomly, so downtown they try to prevent breaks from happening. Those pipes are full, they replace new pipes. It should be nice downtown now. No issues with water. Anywhere else in town though, those pipes are old and they can break at any point in time. And if they break, you could end up having flooding because it's just coming out of the pipe. And so it's into the houses. So they gotta repair that right away. Anytime of night. 2 Fridays ago. Then I went out of town to eat. We came back. It was dark out, it was cold, but there was construction crews right in front of Zayden's house because the water main broke. It was late. Way past their normal hours, like the city crews work till like 5 o'clock. They had to come in outside their hours, so they're probably getting paid extra. So like there's all these different charges that rack up with it, but they had to sit there. I don't know how long they were there, but it was a while because at the point that we drove past, I think they were just like cutting into the concrete. Kind of crazy. But yeah, all those things like add to why they might hurt. It's not a cheap thing to replace that stuff. They had like 5 people out there. It's a lot of money for just one water. But it controls a lot of people's water. So they're an important thing that you want to fix right away. Anyway, that's one reason why I might. Electricity. If this was an electric bill, I don't really know of any reason why like pumping electricity in your house doesn't necessarily break the wires. I mean, it could. If you're using an excessive amount at once, it could like perhaps. But you're more likely to see increases like this on like a water bill, things like that. Like you get something physical from it. Okay, so here's where I put it all together. A gym owner wants to purchase custom wristbands for a marketing promotion. She thinks she will need about 75 bands. Her assistant insists that ordering over 100 wristbands will be less expensive than ordering 75. How can the assistant convince the gym owner? Okay, so we're gonna make a graph to show that, but it's important to look over here on Google Graphics. It shows that each wristband costs a different amount. Okay, so if you were to 0 to 50 wristbands, it's $2 per band plus $20. 51 to 100 wristbands are $1 each plus $10 shipping. And then over 100 wristbands, you're paying 50 cents each plus free shipping. Okay, so the assistant thinks 100 or more is going to be, well, not 100 or more. Over 100 is going to be cheaper overall than only buying 75. Okay, so we can think about this as a piecewise concept. Okay, how would I show this in like a equation form? How would I show $2 each plus $20 shipping? Okay, and you use when they charge this much. 0 to 50. So when x is between 0 rule is 50 cents plus free shipping. So how do I show that one? 0.5, 0.50, 0.5. Well, not because there's 50, like that one. Over 100, let's go there than 100. Okay. So it just sound like weird when we looked at yesterday, and it kind of when you look at something words, because you can see like, oh yeah, this is how I calculate 0 to 50 and I only use it for 0 to 50. This is how I calculate 51 to 100, and I only use it for those numbers. And then anything greater than 100, I use that. Okay, so that's what we're going to look at. And you can either make a graph to show how much the cost is, or we can just plug in 75 into the rule that it would be it and then 100. Okay, so let's say that works. Okay, 75 bands. Would that fall into rule number 1, or rule number 2, or rule number 3? 2. So 75 is between 51 and 100, right? Okay, so we're going to use this rule. 1 times 75 plus 10. What is 1 times 75 plus 10? 85. Okay, and then is this over 100? So if I say 101, which rule would I use? 1, 2, or 3? 3. So I would use rule 0.5 times 101, which is going to be 50.5. Is it cheaper to buy over 100? Quite a bit cheaper, actually. Like, sometimes people are like, okay, this is $1 or $2. I don't really need 25 extra wristbands hanging out of my house for a single $1. You're saving like $35. That was wild. Okay, and let's see if they okay, so they showed everything again like we did. Price times the band plus the shipping. They wrote it out exactly like we did. Except instead of 51, they put 50 there, and then shows not including 55. And so here is the graph version. So if we did 0 to 50 wristbands, like that price actually increases a lot, and therefore they would hope to like make a lot of money. People who don't really use $100. Okay, but then once you get to 50, there's a huge price drop. It goes from $120 to $60. And then it increases, doesn't increase as much. No, it's not as steep of a line. Okay? And then once you hit 100, there's a huge price drop again. It goes from $110 down to $50. And then does this one increase as quickly either? No, it's not quite as steep. So yeah, if you need 100, it's definitely worthwhile to do 100. Because really, it's going to be cheaper to buy 101 over like if I buy 20 wristbands, I'm spending $60. I can buy 101 for $50. $50 is 50 cents. I would buy. But yeah, the gentleman was wrong. The assistant was right. 100 wristbands, higher than 100 wristbands is less money. Okay, so this is similar, same wristband thing. Okay, what is the difference in cost between one order of 200 wristbands, 2 orders of 100 wristbands each, and 4 orders of 50 wristbands? Okay, so let's say, altogether, this is 200 wristbands. 2 orders of 100, how many wristbands altogether? 200. 4 orders of 50 would be how many? 200. So that's 4 different ways to get 200. Sometimes people will just order so many and order more than more. Okay, we're going to see if it's more effective to buy in bulk, right? Or to order along the way. Okay, so let's start with one order of 200 wristbands. Which rule am I going to use? 1, 2, 3. 3. Okay, so we're going to take 0.5 times 200. Try that. I'm going to figure out what it is. How much will it be? $100. And so it's the 200 is $100. That's okay. Okay. 2 orders of 100 wristbands. So there's separate orders. So if I order 100 wristbands, I can do 1, 2, or 3. My goal. 2. Okay. So for that one, I'm going to do 100 plus 10 as my goal. How much is that? 110. But there's that place. So if I did 2 of the exact same order, how much will I spend altogether? Yep, 220 together. Okay. Already is it more effective to buy 200 at once or 2 $100 orders? 200 at once. They save a lot of money. Okay, well, let's look at 50 wristbands. Okay, we're going to do 4 orders of 50. If I'm ordering 50 wristbands, am I going to use rule 1, rule 2, or rule 3? 1. But it's 2 times 50 plus 20. What is 2 times 50 plus 20? And I'm going to do that 4 times. That's how somebody gets here, guys. They would spend almost 5 times as much buying the same amount of wristbands. Okay, so you don't always use like this is a good example of piecewise function that you really don't know. You know, Amazon also does the thing where if you spend $25, a lot of times you get free shipping. But before that, like $24.99, and your candy costs extra. sometimes it makes sense to buy a little more and have to pay that extra. Any questions like that are popping out at you right now? I know this is kind of different. You still look like each piece individual. And I think the story problem is probably the best for people. I don't understand why. It's weird, real life examples sometimes are hard to use on. Okay. Problems, not a lot. Some